here we want to take a look at spherical coordinates. I've created a rectangular coordinate system with the axes highlighted so we can tell what's what. The blue is the x-axis. There's a big blue X on the positive end of the x-axis. The y-axis has a big red Y at the positive end of the y-axis, and then the z-axis has a green Z at the positive end of the z-axis. This is kind of a standard situation, like if we were hand drawing. This would be the positioning of our X, Y, and Z that we would see on a board and on paper and stuff like that. However, with Maple, of course, we can turn and twist this whatever directions we want. Now, I'm just dreaming up a point here. I'm using the point 4, 4, 4 square root of 2, and here's that point in the rectangular coordinate system. You can see if I can twist this some. Here is the point that is on the 4 on the x-axis. Here's the y-axis 4, and see if we can get the lined up 6 thereabouts on the z-axis, probably close to 5 point something. Now, in spherical coordinates, the three components are rho, theta, and phi. I want to describe each of these quantities and show you the representation of that on the graph. First off, the first component, rho, is the distance from the origin out to any point. And we can think of that as a sphere around the origin. Rho represents the radius of the sphere, hence the connotation of using r. The theta is the same thing it was in cylindrical coordinates. The theta is the distance, the angle rather, from the positive x-axis to the vertical plane containing the point we're interested in. Exactly like in cylindrical coordinates. Finally, the angle phi is the angle from the positive z-axis down to the line that goes through the origin and the point. Well, we can think about that as being like a cone, and the angle is from the positive z-axis down to the line that goes through the origin and the point. So it's the angle down from the positive z-axis. You can see that that angle would never go beyond 180 degrees. Now here's the point 4, 4, 4 square root of 2, and I've converted that in Maple to its spherical coordinates, which are 8, pi over 4, pi over 4. Now to do that conversion on your TI-89, you type bracket 4, 4, 4 square root of 2, and then on the catalog you go to the S's and find the triangle sphere, and that'll convert to spherical coordinates. So here's the point 8, pi over 4, pi over 4, and I put that on a graph here to show you the three components. The 8 is the distance from the origin out to the point. So that would be the distance along the edge of this cone that I have drawn on here. The first angle, the pi over 4, would be the theta. Now here is theta. If we look straight down the z-axis, the angle from the positive x-axis around to the plane containing the point. And then finally, the phi is the angle from the positive z-axis over to the line that goes through the point and the origin. Now those are kind of hard to draw by hand, so usually we use something like Maple for drawing graphs in spherical coordinates. Now if we're given an equation where rho is a function of theta and phi, such as the one I've got here, then we can use the plot 3D command, and we have to specify that coordinates, C-O-O-R-D-S, is spherical. So Maple will know to use spherical coordinates. And so we get the 3D graph that we're interested in. If, however, we don't have rho as a function of theta and phi, such as the one I've got here, then we have to use the implicit plot 3D. We still have to do the specification COORDS equals spherical. And we get a nice 3D graph that we can twist and turn and help us visualize.